This is lesson 4-1, Introduction to Functions. Let's discuss some vocabulary. First of all, a relation is the pairing of any two sets. When we're talking about relations, more often than not, we're going to be talking about numbers, but there are situations where we can talk about certain other types of data. The sets that the relation has come from an independent variable and a dependent variable. Obviously, the dependent variable will depend on the independent variable, which can stay on its own. The set from the independent variable, we call that the domain. And those are usually the x values in any given situation. The set from the dependent variable is called the range. And most of our situations when we're using x and y, it's going to be the y values. There are other situations where we'll have to use other letters, and you will see examples of those as we move forward in this unit. A function is any relation that is based on a clearly defined rule. And these rules can come in the form of an equation, a graph that's drawn, a table of values that's given, or a verbal description. The most important thing to know about a function, for any relation to be a function, every input value, which comes from the independent variable or the domain, must have one and only one output from the range or the y values. There are two ways we can test for a function. The first way is we can map ordered pairs. The first thing you want to do is set up a two-column table, followed by identifying your domain and range, and drawing arrows from each of the values to match them up. If more than one arrow is drawn from any of the independent values or domain, the relation is not a function. The other way we can test, and we use this test when we have a graph, is called the vertical line test. If the graph is given to you, this step is not necessary. If the graph isn't given, you want to plot points and connect your points if the relation is a continuous function, meaning that it needs to be drawn. Next, draw vertical lines, and again, vertical lines are ones that go up and down. Draw vertical lines all over your graph anywhere you want. If any of the vertical lines that you drew passes through any of your graphs or your drawings more than once, the relation is not a function. Let's take a look at some guided examples. Let's take a look at mapping ordered pairs. So I have a set of ordered pairs, and you know that normally ordered pairs go as x, y. So I'm going to set up an x column, and I'm going to set up a y column. My x column will have 3, 5, 7, and 8. My y column will have 6, 7, and 9. No need to write the 7 twice, even though it appears twice. Now, I want to draw arrows from the x values to match them up with the y values. Remember, my x is my domain, and my y is my range. 3 goes to 6. 5 goes to 7. 7 goes to 7. And 8 goes to 9. Because each of the x values has one and only one arrow, this is a function. Remember, I am not concerned about the y values when I am testing for a function. On the right, you see a vertical line test. We have the graph already drawn for us. Now, I can draw vertical lines all the way throughout the graph. the easiest way to draw the vertical lines is to use the vertical lines from the graph itself. You'll notice these lines right here, I never hit the function. That's perfectly fine. With this line next to it on the right, I hit the function once. This line hit the function once. This line hit the function once. This line hits the function once. And the rest to the right do not hit the function at all. Because all of those vertical lines only hit the drawing or graph once, this is a function. If it hit more than once, it's not a function. Here's some examples for you to try. You have one mapping and two vertical line tests to do. Pause the video at this point to give yourself a chance to try it on your own. Let's do the mapping of ordered pairs first. We have x and y. The x values that I see are -4, -1, and +1. The y values that I see are -6, -2, +2, and +4. Let's map. -4 goes to -6. 1 goes to -2. -4 goes to 4. And -1 goes to 2. Notice with this one right here with -4, it has two arrows coming from it as an x value. This is not a function. On the right, the vertical line tests. Again, draw your vertical lines. And in this first graph, you'll notice that I have never hit the drawing in black more than once. This is a function. Let's try the second one. I'm drawing my vertical lines. I'm only hitting the black graph more than once so far. But wait, now I've hit it twice. I'll hit it 3 times here. It only takes one example, but I have 2 there, where the vertical line is hitting the graph more than once. This is not a function. Let's talk about functions as models. Functions are very useful when they can be modeled in situations in various ways. Notice the graph at the right is a function because it passes the vertical line test. Let's take a look at the situation. Notice what you have on the right side, distance from school in blocks. On the bottom, time spent traveling to school in minutes. It's important to make sure that we are reading all axes when we have a graph. Here's the situation. The graph to the right models Charlene's travel to school. Her distance from school in blocks is given as a function of time in minutes. Here are the questions about the graph. How far is Charlene's house from school? How far away is the school after she has walked 4 minutes? After 6 minutes, Charlene stops to look for her subway pass. How long did she spend looking for it? Charlene finds her pass and walks to the subway station. How far away was the subway station? And again, that question is implying from where Charlene stopped to find her pass. And then, how long was her subway ride to school? Pause the video at this point to give yourself a chance to try these questions on your own. Here are your answers. The first question, how far is Charlene's house from the school? We want to take a look at the y-axis here and notice where she started. Notice, by the way, that each of our lines are going up by 2. And you're more than welcome to write these out. I would recommend it. So the first question, how far is Charlene's house from school? 22, and they give you right here the unit of measure, blocks. Next question. How far away is the school after she's walked for 4 minutes? Each of these units with the minutes is going up by 1. Here's the 4-minute mark right there. She is 14 blocks away from school. Next, after 6 minutes, Charlene stops to look for her subway pass. How long does she spend looking for it? At the 6-minute mark, she stops. It is flat here, so she has not moved until this point right here at the 9th minute. So she's gone from the 6th minute to the 9th minute looking for her subway pass. It took her 3 minutes. Next, Charlene finds her pass and walks to the subway station. How far away was the subway station from where she was? This is where she gets on the subway right here. Now, I'm going from the 10 blocks away. Now she's 12 blocks away. The subway station was 2 blocks away. If you're wondering why she would have gone backwards, quite possibly, maybe she realized she wouldn't make it to school on time at that moment, so she decided to take the subway. How long was her subway ride to school? We are at the 11th minute when she gets on the subway, and it is clear that she's moving quicker at this moment. So, we go from here to get to school. It's the 11th minute to the 15th minute. Her subway ride was 4 minutes. If you're having any issues with any portion of this lesson, please make sure you are emailing me or consulting me in class.